In this video, we are going to talk about adding rational numbers. Now that we've talked about fractions and decimals and what rational numbers are, we're going to start using operations with them, and we're going to start with addition. So our essential questions for this lesson are: how do you add positive and negative decimal values? How do you add positive and negative fractions or mixed numbers with the same denominators? How do you add positive and negative fractions and mixed numbers with different denominators? And how do you add decimal values to fractions? So now we've got a mixture of all these types of numbers that we're dealing with, and how do we do addition with them? So let's start with adding decimal values. Recall that when you're adding decimal values, you always have to add the same place values together. So you've probably learned how to line up the decimal places and line up the place values and then add. So if we had 5 and 97 hundredths plus 2 and 1/10, we would add it similar to this, lining up our place values here with our hundredths together, our tenths together, and our ones placed together, and then just adding and carrying and bringing the decimal down. Just a quick review there of adding our decimal values together. But what happens when we have positive and negative decimal values together? That might be something that is new to us. We're going to use the same rules that we used for integers. So remember, when we were adding integers, if they have the same signs, their values will combine. So a negative plus a negative is even more negative. Those values will combine together, and then a positive plus a positive becomes more positive. And then if it's a positive and a negative added together, they're going to cancel their values out. So that's kind of like subtraction. You're taking away there. So we're still going to use those same rules that we've learned, but now we've got some place values to keep track of here. So here's some examples of adding some positive and negative rational numbers in decimal form. Here we have negative 8.45 plus negative 3.4. These are both negative numbers, so their values are going to combine. So I am going to combine their values together, and I know that this answer is going to be negative, but just how much negative I need to figure out. So I add these together, adding their place values together, and that's 11.85. And since these were both negative, I know my sum is negative 11.85. Next one, 15.05 plus negative 3.4. Here we're adding a positive and a negative together. So these values are actually going to cancel each other out. So this is basically like subtraction. I'm taking 3.4 away from 15.05 because adding a negative would bring that value down. So this is basically like, like subtraction. So I'm going to take away 3 and 4/10. That's 5. Here I'm going to borrow 10 minus 4 is 6. Bring the decimal down, 1 and 1. And that's a positive 11.65 because there was more positive in this problem than negative. And then lastly, negative 19.8 plus 5.66. Again, these are going to be canceling each other out, but my answer or my sum is going to remain negative because I'm only increasing this value by 5.66. It's not enough to get me to 0, and it's not enough to get me to the positives. So if you're thinking of that number line, I'm at negative 19.8 and I'm moving to the right. I'm getting larger, but I'm still going to be in the negatives, but I'm going to be less negative. So I'm basically taking away 5.66 from 19.80. Here I'm going to borrow 4, 1, bring the decimal down, 4, 4, and I know that's going to be negative 14.14 because I went less negative on the number line but didn't quite get to the positives. So that's adding our decimals together. Remembering the same rules we used for integers. Adding fractions and mixed numbers with the same denominators. Well, when we add fractions together, we're going to just add the values of the numerators and simplify the fraction as needed. It's probably the easiest when we have the same denominator because we're talking about the same size pieces. So then we just need to add the number of pieces we have together. Again, using the same rules we use for integers with the numerators. So if the signs are the same, they will combine. If the signs are different, they will cancel. Mixed numbers get a little bit more difficult, especially when we're adding positives and negatives together. It's best to make the mixed numbers into improper fractions first, and that will eliminate a lot of issues and problems and errors that 7th graders have when they add positive and negative mixed numbers together. Then add the values of the numerators just like they're fractions, and then simplify as needed. So just turn them into fractions, and then we would just basically use these rules over here for fractions. So let's look at some examples. 5/7 plus 5/7 plus 6/7. Here we have the same size pieces, which are sevenths. So my answer is still going to be in sevenths. And 5 plus 6 I'm going to use my addition rules for the numerator. 5 plus 6 is 11. And so that's 11/7, which as a mixed number is 1 and 4/7. And there's my sum. Next one, -3/8 plus 5/8. Remember, this negative is kind of associated with the numerator, so it's like -3 plus 5 in the numerator, and they're both eighths, so my answer is going to be in eighths. And -3 plus 5, that's a canceling, and there's going to be more positives less, and that's 2/8. And we can simplify that fraction or reduce it to 1/4. So there's our sum there, and that's positive 1/4. 4/10 plus -5/10. Again, we have common denominators, so the numerators are going to be 4 plus -5 and 4 plus -5. This is a canceling. That's -1, and we are talking about tenths, so that's -1/10, and that is in simplest form. And then lastly, -7/13 plus -9/13. These have the same sign, so these are going to combine. A negative plus a negative is going to be even more negative, so that's -16/13, which is an improper fraction. So we can write that as a mixed number, -1 and 3/13. There's our sum there. So adding fractions and mixed numbers with the same denominator is quite easy to do. Here's a few more examples of mixed numbers, positive and negatives. These are the ones that get a little bit more complex if you don't change these into fractions. So I just want to show you that changing mixed numbers into fractions makes our chances of making a mistake go down quite dramatically. So 3 and 5/6 as a improper fraction would be 18/6 plus 5/6, which is 23/6, plus -13/6. Those are those mixed numbers as improper fractions. And then if I add the numerators, 23 plus -13, that's like 23 minus 13. So that's 10/6, which is 5/3, or 1 and 2/3. Positive 1 and 2/3. Next one, -1 and 2/5 plus -4 and 4/5 as improper fractions. These are -7/5 plus -24/5. And these are the same sign. A negative plus a negative is even more negative. So -7 plus -24 is -31, and they are fifths. -31/5, which is -6 and 1/5. And the last one here, -5 and 3/8 plus -6 and 1/8. This one, you could go either way by just adding the whole numbers and then adding the fraction values together. But we'll do the improper fraction route just to show you. This is -43/8, and this is -49/8. And when we add those together, we get -92/8, which is -11 and 4/8. Or -11 and a half is our answer there. So adding fractions and mixed numbers with common denominators or like denominators is quite easy to do. What happens when we have different denominators? We don't have the same size pieces. Well, we have to add a step to that. Our first step is to rewrite the fractions with common denominators. And the common denominator of any two fractions is their least common multiple. If you can't recall how to find the least common multiple of two numbers, I'll add a video to this module to remind you how to find least common multiple, but I'm not going to talk about that in this video. And then once we get common denominators, we add them just like we added our fractions and mixed numbers previously in the previous examples when they did have like denominators. And the same with mixed numbers. We need to get common denominators, turn them into fractions, and then add their numerators using our rules for integers. So let's take a look at some fractions that do not have common denominators. 2/3 plus 4/5. Well, we're looking at the denominators 3 and 5, and we're looking for the least common multiple of 3 and 5. So their least common multiple is 15. That's the smallest number that 3 and 5 will both divide. And so we're going to rewrite these fractions as 15ths. 2/3 is 10/15, and 4/5 is 12/15. Now we have common denominator, and we can add them just like we did our previous examples. And this is 22/15, which is an improper fraction, which is 1 and 7/15, and that is in simplest form. Next one, -5/6 plus 1/3. 6 and 3 are the denominators, and the least common multiple of 6 and 3 is 6. So our first fraction will remain negative 5/6. And we're going to rewrite 1/3 as sixths, which is 2/6. And now we'll add the denominators using our rules for integers. Negative 5 plus 2 is negative 3. So negative 3/6, which does simplify to negative 1/2. And there's our result there. And the last one, negative 1/2 plus negative 6/7. The least common multiple of 2 and 7 is 14. So we will rewrite these fractions with a denominator of 14. Negative 7/14 is equivalent to negative 1/2, and negative 12/14 is equivalent to negative 6/7. And then these are both negatives. Negative 7 plus negative 12 is negative 19. So we have negative 19/14, which is negative 1 and 5/14 as a mixed number, and that is in simplest form. Now let's look at some mixed numbers here. 3 and 3/5 plus 7 and 7/10. The least common multiple of 5 and 10 is 10. So I'm going to rewrite these with a denominator of 10. 3/5 is 6/10. And this one is already tenths, so I'm going to leave it written like that. And then I'm going to change these to improper fractions. This is 36/10 plus 77/10, which is 113/10, which is 11 3/10 as a mixed number. Next, negative 6 and 2/3 plus negative 8 3/4. Our least common multiple of 3 and 4 is 12. So this is negative 6 and 8/12 plus negative 8 and 9/12 once we get our common denominator. And then we can, since these are the same, we can add the whole numbers and add the fraction parts together, or we can write these as improper fractions. It really doesn't matter in this case when you have the same signs, but I'm going to continue on with the improper fraction route. Negative 6 and 8/12 is negative 80/12. And negative 8 and 9/12 is negative 105/12. And when I add these together, I get negative 185/12, which is negative 15 5/12 in simplest form. And then lastly, 9 1/2 plus negative 6 1/8. The least common multiple of 2 and 8 is 8. So this is 9 4/8 plus negative 6 1/8. And as improper fractions, we've got 72 plus 4, 76/8 plus negative 49/8. And 76 plus negative 49 is like 76 minus 49. And that gives me 27/8, which is 3 3/8 as a mixed number in simplest form. So adding fractions and mixed numbers with unlike denominators, you have to get that common denominator first. Lastly, adding decimal values and fractions. When we have a mixture of rational numbers in decimal form and in fraction form, we're going to convert the fraction to the decimal and then add the numbers like decimals, because that seems to be the easier route to go rather than finding common denominators and converting decimals to fractions and so on. It just becomes more work to change everything to fractions and get that to work. So here we have 2.6 plus 3 1/5. Well, 3 1/5, we would change the 1/5 to a decimal, and 1/5 as a decimal is 0.2. So this is 2.6 plus 3.2. And when we add these together, we get 5.8. And we would leave it like that. Next one, 3/4 plus negative 0.5. 3/4 as a decimal is 0.75 plus negative 0.5. And again, these are positive and negative added together, so they're going to be canceling. So this is like subtraction. I'm reducing, or the value is going down by 1/2, and that gives me 0.25, positive 0.25, and we are done there. So adding rational numbers, remember, we're still using the rules we used for integers. If the signs are the same, they combine. If the signs are different, we cancel.